Hello dear learners, I am Mrs. Tejal Bhave, Assistant Professor at dtss College of Commerce. In this tutorial series, we are going to discuss about double linked list. Let me now take you to the subtopics that we will cover in this video tutorial. Firstly, we will briefly define what is double linked list. Then, we will see the structure of double linked list and its operations. So friends, what is double linked list? It is a linear data structure where all elements are arranged subsequently. A double linked list is a fundamental data structure. It consists of nodes where each node contains a data field and a reference to the next node and a previous node in a linked list. The previous field of first node is null and the next field of last node is null, indicating the end of the list. Basic terminology of linked list is the node contains of three parts: previous pointer, data and next. Now what is node? Node is the element in the linked list which consists of three parts as previous node, address, data part and next node's address. Previous pointer. It gives the address of previous node in the double linked list. Data is used for storing the value. Next pointer gives the address of the next node. Now let's discuss about basic operations on double linked list. The basic operations on double linked list are insertion, deletion, searching, traversing. The operations are usually performed to either modify the data in the double linked list or to report the status of the double linked list. Following are the basic operations supported by the double linked list. First is traversal. Linked list traversal refers to the process of accessing each element of the linked list in sequential order, the beginning to the end or from the end to the beginning. Insertion. Insertion is the process of adding a new element, that is a node, to the linked list. Depending on the application, new element can be inserted at the beginning, at the end or at any other location within the linked list. Now deletion. Deletion is the process of removing an existing element from the linked list. Depending on the application, the element can be or the node can be deleted from first, from last or in between. Now search operation. Search is the process of finding a specific element within a linked list. This is done by comparing the target element with each data part in the node in the linked list until we found the match with the value. Now we will see each operation in detail. First operation is traversal operation. Linked list traversal refers to the process of accessing each element of linked list in a sequential order. Traversing a linked list involves visiting each element of the linked list in a specified order, typically from the beginning to the end or from the end to the beginning. For the traversal of double linked list, we need to assign a temporary pointer which is called as current pointer to the first node of the linked list. Then the current pointer will be incremented as we traverse the linked list towards the end. Now this will be the algorithm for the traversal. First step will be initializing a current pointer to the first node of the list. Then we have to loop it through the list using a while loop until the current becomes null. This processes each node and prints its data. Now move to the next node by updating current to the current's next. Next operation is insertion operation. Insertion in a double linked list refers to the process of adding a new node in a linked list. There are three cases while inserting a new node in the linked list. We can insert a node at the starting position, at the end, or we can insert at the specified location. We will see all the cases in detail. Insert a node at front or beginning of the double linked list. To insert a new node at the front, we create a new node and point its next pointer to the current first node of the linked list. Then we update the head pointer to this new node. New node's previous pointer will become null as there will not be any other node before that. Now insertion at the end in the linked list. Inserting at the end involves traversing the entire list till we reach the last node. We then set the last node's next pointer to point to the new node, making a new node as the last node in the linked list. After insertion, we will make the next pointer of new node as null, as it will be the last node of the linked list. Now the third case is inserting a node before a given specified position in the doubly linked list. If we want to insert a new node before a given node, we first locate the node while keeping the track of previous node also. For that, we have to traverse the list until we find the actual value by which we want to insert a new node. Now, we assign the previous node's next pointer to the new node as well as a new node's previous pointer to that node. In this example, we need to insert in between 2 and 4. So we will create a new node with the data part as 3, and 3's previous pointer will point to 2 and 2's next pointer will point to 3. Similarly, 3's next pointer will point to 4 and 4's previous pointer will point to 3. Now we will say deletion operation. Deletion operation means removing the node from the linked list. Before deletion, we must check whether the linked list is empty or not. If it is empty, then we can display an appropriate message. Now deleting a node in the linked list is an important operation and can be done in 3 main ways: removing the first node, removing the middle node, or removing the last node. We will see the first way, that is deletion at the beginning of the linked list. To perform the deletion, if we want to delete in the first position, we update the head to the next node and the current head, delete the current head. For other position, we traverse the list to reach the node just before the specified position. If the target node exists, we adjust the next of this previous node to the point to next nodes, which will result in skipping the target node. Now, deletion at the end of linked list. Check if the list is empty or not. If it is empty, then we are going to display the appropriate message. If head is null, that means your linked list is empty. Then there is nothing to delete. If the list has only one node, simply set the head to null when we delete the element. Now traverse the list to find the second last node. Start from the head and iterate through the list until you reach the second last node. Now update the next pointer of the second last node. Set the second last node's next to null. Delete the last node. The last node is now unreferenced and can be deleted or freed depending on the language used. Now the third way is deletion at specific position of the linked list. Deletion at a specific position in a doubly linked list involves removing a node before a specified index or position, which can be first, middle, or last node. In this example, we are going to delete after a node with the data part as 1. That is a node containing data as 2. After deletion, the next pointer of 1 will point to 3, as well as the previous pointer of 3 will point to 1. Now we will see the search operation. Searching in a linked list involves traversing a linked list till we find a specified value. We have to traverse the doubly linked list for searching the particular value. We need to assign the current pointer to the first node of the linked list and increment it till we reach to the given data while comparing the data part. So this is the doubly linked list with the operations as traversal, insertion, deletion and searching. Thank you so much.